speak about deepfake video, how they are created, and how to detect them, and what is the role of explainable AI. And just a brief introduction about myself. I have a PhD in artificial neural network, and I have this opportunity to work in most of the universities as a research fellow, as a postdoctoral researcher. And these days, I am working as a senior lecturer in University of East London. Before this, I have been in universities like Brunel University, Middlesex University, and University of Ulster. And my background is artificial intelligence. I've been associated with multiple projects that involve computer vision, that involve natural language processing for data visualization, for association extraction, and things like this. One of the biggest projects that I have worked with is something called as Valkyrie, which was sense making of the crime data using natural language processing. And we worked with the 10 different countries of the Europe to develop the product. Having said that, today my agenda is that I would be highlighting some understanding about the deepfake video. And in doing so, I will tell that how the deepfake video is created, what are the challenges of the deepfake videos, and can we use explainable AI to detect and to explain the deepfake videos, and what is the future direction of this video. So before I start, let me show you a video. Can you confirm if you can hear this voice? Guys, can you hear me? Hello, can you hear me?
Yes, the video audio is not coming, video is playing.
Okay, I think the reason is probably I'm sharing a YouTube video. Basically, this is a deepfake video of Morgan Freeman, and it looks real. And he's talking about something related to the deepfake videos. So the idea here is that in this technology era, the videos that has been developed and this has been created are so real that one it is very hard to identify what is the real and what is the fake. So like before the AI, it is believed that what you see is the truth. But in these days, this proverb does not, I would say, apply correctly, because in these days, seeing is not believing at all. So the question is, can we actually trust what we are looking at? Can we see that whatever the pictures, whatever the videos that we are watching are real? Because these deepfake videos is creating a positive and a negative impact on the society. For example, they can be used for the political purposes. For example, they can be used to defame someone. So this is very high demand that there should be some tools, there should be some software, there should be some technology which already is there and is developing to identify these deepfake videos. One of the things is that in identifying the deepfake video, how can we actually ensure the authenticity of this video content? And whatever a person is saying in the video, can technology help us to make it confirm that these words, these emotions, these gestures are real from the real personality? Okay, so what is a deepfake video? A deepfake video in its definition is something which is basically digitally synthesized. It can be a text, it can be a graphics, it can be a video. But one thing is sure about this, that these digitally created media is not real. And these are manipulated videos or images that appears to be real, but in fact they are not. So how they are created? They are actually created with something called as deep learning algorithms. And the deep learning algorithms manipulate or replace the existing videos or images in the original video. So what happens is it may change the face of the person in the video, or it can change the speech of the person in the video, so that what you will see is that something that the person is not saying. Uh, the deep learning algorithm that is used in detecting these kind of media are convolution neural network, generative adversarial network, recurrent neural network, capsule network. So these are the most prominently used networks, which basically are or is being used in the creation and at the same time detection of the deepfake videos and deepfake images and deepfake content. So before I proceed further, just to give you a very quick idea about deep learning. So machine learning has been there quite long, and it was doing the job very successfully. So what happened in the machine learning languages or machine learning domain is that you have something, for example, if you want to do some kind of classification, then you need to determine some kind of a feature that can identify this object, which is a process of feature extraction. And then you have a process of some classifier which actually create or which actually identify whether some object is some car or not. However, the deep learning changes this entire domain. And rather than a person, a machine learning engineer, basically works towards the feature extraction and define the feature which is needed for a particular algorithm. Now the deep learning taking this responsibility with the help of convolution neural network and with the help of multiple hidden layers, so that this feature extraction process is now eliminated, and this is incorporated into the algorithm classification algorithm itself. So now machine learning is I would say advanced to a level where the machine learning engineer explicitly does not need to work towards the extraction of the feature. Rather, it is the job of the algorithm which is basically used for the classification. For example, the convolution neural network. Now, one more thing about the deep learning is that deep learning is a multi-layer architecture, which means that, like, if you go back about sometime 20 years back, then it is said that if you have a 3-layer architecture having one input layer and one output layer and one hidden layer, then it can be used for almost every problem. However, this principle or this notion or this myth was basically broken or rejected by the invent of the computer vision algorithms, and now we are actually using many multiple hidden layers algorithms which are very successfully identifying, recognizing the object in the field of computer vision. On the other hand, one of the important bit that I want to mention here is that what is the need of the deep learning? So what happens is that as you are training the data, because data is the important part of AI, and AI is the data hungry applications. So what happens in the traditional machine learning is that as the amount of data is increased, then the learning capability or the learning performance of a traditional machine learning algorithm remains constant. Like if you add more data, it does not make any sense. However, with the deep learning infrastructure, with the deep learning architecture, the performance, the accuracy increased sharply. So this is the reason for the last in the last decade, deep learning has actually revolved in fact, every field from natural language processing to the computer vision, and even with our chat GPT, it is all the deep learning. So if you understand this bit, now we can identify how a deepfake video is created. In order to create a deepfake video, what you need is two main videos. One we call as source video or a source image if you are making image as a deepfake image. So the source video is basically the original video or the original footage of the person whose face or voice is going to be manipulated or going to be changed or going to be replaced. And the target video is the video that is going to be manipulated or replaced in the original or in the source video. And these two videos are then fed into deep learning algorithm, which basically applies some technique, I would say, to create a deepfake video. For example, in this particular case, I have got a source image and I have got a target image. And with the help of some algorithm, for example, GAN, I have created a deepfake, which basically something which is mapped on the target image. So what is the generative adversarial network? This is the key, I would say, or this is the main algorithm which is being used, or I would say this is basically the pioneer of today's modern of deepfake content. So this was basically developed sometime in 2014. So the idea is that suppose there is a policeman and there is a thief. So what is happening between these two characters is that the generator have got some fake currencies, and the policeman is checking these currencies, and when it's identified that this currency is fake, then the generator, which is a thief in this case, adopts new technique to show that the currency it has got or he has got is not fake by the feedback of this policeman. So if you understand this idea, then we can understand that how the generative advisor network is used to create fake data. So this GAN actually have got two network or two algorithm. One we call generator and the other we call as discriminator. So this discriminator have the input of the real data as well as the fake data, and it classify this thing either as a real or as a fake. And this generator responsibility is to generate the fake data, not the real data, but the fake data. So let me give you some more detail on it. So this is how it works. I have got a generator here. This is the discriminator, and this generator actually works on some noise, and the purpose of this generator is to generate a synthesized data, which is a fake data, which resembles or like the real data, but it is not the real data. And this discriminator is a classifier, and it has a tendency or the attribute or the ability to classify or to identify the real data and the fake data. So it can identify either it's a real or fake. So if you understand my last example where I mentioned about the currency note, so if the discriminator says that this currency note is fake, then this is feedback to the generator here. And generator then, based on the feedback of the discriminator, adopts new technique to produce something which actually should be identified as real by the discriminator. Until the discriminator keep identifying that the data that is generated by the generator is fake, this generator keep training itself. So this is a very, very interesting and very, I would say, useful concept, because it is performing two bits here. One, the generator is generating the data which looks like the real data, but it's not the real data. And two, the discriminator has this probability of identifying if the data is real or fake. So both the discriminator and the generator actually work together. In this particular case, the discriminator is a classifier which actually identifies the real and the fake images, and it is trained first before the generator, because once it is trained, then only it can identify whether the thing that is being passed to it is real or fake. When the discriminator has got some tendency to identify, or it is trained enough, then the training of the discriminator starts, and the training of the generator starts. And this generator then taking the input which is called as a latent sample, and generate a fake data. Now, because the discriminator has been trained, so it can identify. So this process goes on until the discriminator fails to identify the data which is fake and identify it as a real. At this moment of time, the generator stops its training, and it says that generator is now fully trained to generate the fake data. So in this case, both the generator and the discriminator has been trained. So if you want to check that if something is real or fake, what you have to do is you have to pass that unseen data set where to the discriminator, and the discriminator then identify if it is real or fake. So I can give you some example of the GAN applications. There are many examples which is very much prominent these days. As my previous presenter has mentioned, that these days AI can generate the entire script of the movie, can generate the songs, can write down the articles, the poem. This is all of these applications are using inside them the GAN in different architecture or in different forms. GAN can be used to convert text to the images. One of the important, one of the interesting application is that GAN can convert something in the foreground to some other object, keeping the background as it is. For example, here, this is a very good example. If you look at it, that the foreground is changed from zebra to the horse, but the background is still same. This is another property or another application of the GAN architecture. However, in doing so, researchers have adopted different version of the GAN. Some have adopted, for example, deep convolution neural network. Some applications are implemented using cyclic GAN, for example. One of the another application which is very interesting to understand to know it, that now GAN has got this ability that they can actually predict what can be happen in the next frame in a video. For example, look at this. There are two characters here, and this scene suggests that they might hug each other because of the gestures that is representing in this frame. And this is how the GAN actually predict what could happen in the next frame. So imagine where this world would be going because of the creation of these things, that you have now maybe a movie script that would be generated by the AI, or you would have something that could be predicting about the sequence of the scenes in a movie. So as I mentioned, there are different type of GAN that has been used. The very easy one is, I mentioned, vanilla GAN, where we have got the two network. One is the discriminator and the other is the generator. However, as we move on, then this GAN architecture has developed or evolved. So the very much commonly used is called as deep convolution based generative adversarial network, and these are not fully connected. The other ones which is used for the image to image translation is called as cyclic GAN. These are just a few examples of the GANs that I have mentioned. There are other as well which has been used in the research. So now when we have some idea about that, what is the GAN, how does it work, what are the different type of the GAN, what are the application of GAN, I would like to show some thing about how to create the deepfake videos and what are the different techniques that you can use. So the deepfake videos or deepfake media can be created in two ways. Either you have an image and a video, which are both fake, or you have just audio. If in case of the deepfake video having the images and videos, there are different techniques that is being used. For example, image face swapping, puppeteering, lip synchronization, whole body manipulation, speech synthesis. These are all the common methods of creating the deep fake media, including deepfake video and deepfake images. So how does this deepfake generation works using the generative adversarial network? So let's talk about the face sweeping, that how does the face sweeping is performed. So what happened is that as you can understand that in the face sweeping, the face of the person is replaced in the target video with the face of the other person, while trying to preserve the facial expression and the lip movement in the original video. So the first bit is that you actually, or the procedure or the pipeline, basically, first of all, extract all the frame from the source and the target and videos, and then identifying the faces and align them. Then the GAN or an autoencoder are used to convert the face from one face to the another. And once this is done, then finally the video is created to merge the two faces. For example, here, this is my original frame. So I applied some image processing technique to define or to identify the face and then align it. Now, with the help of the GAN or the auto encoder, this face are mapped in a way that we can generate the new faces with the help of face A and face B, and then we actually produce or replace this face into our original video. So this is basically a kind of a basic idea that how you can actually create the deepfake video. Another way of doing the deepfake video is lip synchronizing. As you can see here, that in this particular video, we have got a deepfake video and we have got an original video. So in this particular video, with the help of the lip synchronization technique, the person is saying something which he never said. So this is another form of the deepfake video. So the lip synchronization process involves extraction of the facial landmarks and the movement, and then in the source video, and then we align them with the audio of the target video. So in this way, we can generate media for a person by changing the speech, and it would be again kind of a fake content because it is impersonating someone's voice. So let me give you a detailed understanding of the deepfake video generation to the GAN. One important thing to understand here is that the GAN, if you want to give or if you want to train for the deepfake video, you should be passing not the images but rather the videos in order to generate the deepfake videos. And then, as I mentioned earlier, that we have to actually apply some facial tracking algorithm to track the movement of the target face in each frame of the video. So here is the basic understanding. So, we first collect the data, then using and this data should be the source video as well as the target video. Then we train the GAN, and once we train the GAN, then we actually extract the target face feature and create a 3D model of the target face. Then we map this target face model to the original video, which actually create the generated deepfake. So this is the overall process where we can show that how generative adversarial network maps the created 3D face model of the target over the face of the source video. So let me give you an example. This is a very good example. I have found it from the YouTube. And in this example, what happened is that James Bond, that was played initially by the Sean Connery. So one of the scene is recreated using the deepfake technology, and Timothy Dalton can be seen to be in the video. However, it's a fake video in a sense that the actual scene has performed by the Sean Connery, but with the help of the deepfake video, we have swept the face of the Timothy Dalton over the face of the Sean Connery. And the idea is still the same, that first of all, the feature vectors or the facial feature are extracted from both the source video, which is the Timothy Dalton, and the target video, which is the Sean Connery. Then we actually create some facial landmark which basically identify the key point on the faces, such as nose, such as eyes, such as lips. Okay, and then we create a 3D model for it. After this, both the faces in the two videos are aligned so that the facial expression can be mapped over each other. Then a GAN model is trained to generate fake images of Timothy Dalton and the Sean Connery. And finally, this basically create a deepfake video, which I'm going to show you now. So this is basically, let me see if my net is working fine to you. Yeah. So this is Sean Connery, which is the real, and this is Timothy Dalton. And you can see that it is perfectly performing exactly the same gesture, the same facial expression, okay, but this is not real. The actual one is the Sean Connery, and the deepfake one is the Timothy Dalton. So now we understand how to create the deepfake video. The point is how to detect the deepfake video. There are a lot of methods reported in the literature. Some are based on the network base, which are the general networks, or which are based on the deep learning. Some are based on to identify the temporal consistencies in the frame, which means that we have to check out as the frame move from then what is the temporal effects in the frames. Then some methods are used using the visual artifacts method. Some method which is very interesting is use on the biological signals, which means that they can identify the heart rate and eye blinking in the video, and from there they can identify if some video is fake or not. In addition to this, there are some methods which are handcrafted method. In this way, the image processing techniques are applied for the face detection, for the lip synchronization, or the motion analysis. However, today I will be going to talk about something called as transfer learning based methods, that how we can actually detect the GAN created deepfake video using the transfer learning, and how effective is this technique is. However, I would also like to highlight here that in addition to the transfer learning based technique, the latest domain or the latest train is something called as capsule network. It is also very very effective in detecting the deepfake video. So before I actually give you how to create it using the transfer learning, if you actually have to identify a deepfake video, what will you do? Or how will you say that this video could be a deepfake video? There are some very basic critical thinking based questions. Number one, who and why is someone sharing this? What could be its agenda? If it has been shared on the social media, for example, then what could be its effect? This is the first thing one should ask in order to check if this video belongs to the real or an authentic or otherwise a fake. And then where is this video coming from? What is the website? What is the group, the social media group that is basically putting up this video? That is very important to know. Maybe some might have got some political interest into it, or some religious interest into it. So these are some basic questions that one should understand. And then where this video was developed, or when was it created? This also gives some understanding that is the video that is coming up, or is it fake or real? And then the second important thing one can consider is that whatever the person in the video is saying, does it actually mean it? Like, if we can expect something from this person to say, and thus is there any hidden agenda in propagating this video? In addition to this, if you want to observe the technique or technically that if some video is a fake or not, the first thing I would mention to check is that check the face closely to determine if it appears to have been manipulated. Check the facial skin. Is it appearing too smooth or too wrinkly? Or determine if the skin, hair, or the face and the eye matches in terms of ageness. These are the first thing that one should identify if you doubt that some video is fake or not. Okay. In addition to this, one can also check the facial hair. Are they appearing real or fake? Another important bit is to check the eye blinking, because in the most of the videos, in the fake videos, the eye is not blinking or is not blinking normally. So this is the second important thing one should check in case of a deepfake video. Then the color of the lip, is it similar to the rest of the body color? These are some of the technicalities that one can follow or check in order to check if a video can be fake or not. For example, here I had taken this picture to show you that manually or can you actually determine if a video is fake or not. For example, here if you look at it, there are two halves of this image or the picture. One half is very much clean and very much without any problem. However, the eyes, the blinking of the eyes is not consistent. Similarly, there is a mismatch earrings here. Some feature lacks definition. So these are the basic or common things that one can see in the video to identify if the video is fake or not. Now, this technology in the recent year have been worked very much, and there have been some development regarding the deepfake data. One of the very important data that one can use is called the celebrity faces. This celebrity faces have got data over 200,000 celebrity faces, which have labeled as fake or real. So this is where most of the researchers are applying their proposed algorithm to identify if some video is fake or not. Similarly, another data set that we have got is the YouTube face data set, which is also being used for the same purpose. The latest one is the deepfake detection challenge data set, and this is about 100,000 videos, including both real and fake. These are the two most prominent ones which is being used in order to detecting the deepfake video. The third most commonly one is called face for Sonic. This is also a good data set to use for the deepfake video detection. So now let me come back to my how we can use the transfer learning in order to detect the deepfake video. Just to give you some understanding about the transfer learning. Transfer learning is that branch of the machine learning which basically transfer the knowledge which is learned in some other task. So what is the knowledge actually? The knowledge is nothing but the weights that a network or a neural network uses in order to classify or in order to do some solution for some given problem. So what happens in the transfer learning is that if an algorithm has learned a knowledge, then this knowledge can be transferred to solve another problem. The problem could be the same domain or could be a same problem. So transfer learning differs from the traditional machine learning that it uses predefined trained models, for example, VGG, for example, inception models that has been trained on the thousands of data, and which means that they have got some very good weights that can be used to identify, to solve some other problems. So a pre-trained model is a model that was trained on a large benchmark data set to solve a problem similar to the one that we want to solve. So there are two basic forms of the transfer learning. One we use for a feature extraction. And in the feature extraction, what we do is we actually freeze all the layers and pass the data as the input and get the feature at the output of the pre-trained algorithm or pre-trained model. And these features then can be fed into the another classifier. This is the first form or the one way of using the transfer learning. In the another form of transfer learning, what we do is we again use the pre-trained models. However, here we actually either fix some of the layers and fine tune it to the data that we are passing to it, so that we actually use the weights that was there. However, we retrain some of the layer for our given data set. That is what we actually use when we use the cloud computing environment. And the most prominent pre-trained models that is there are VG16, VGG19, inception model, exception model, ResNet model. So these models are used for the either the feature extraction or to solve some problem which is similar to them. Okay. One of the things that I have used using the transfer learning base was a human activity recognition. So in general, we use some IoT devices to identify the activity of the human. However, in this case, what we did was we actually use a pre-trained model and to extract the features, and then we use these features into a CNN and LSTM based classifier to identify the activity of the human, so that this algorithm can incorporate to a camera in a smart home where it can identify that what a person is doing, and this can suggest or this can help in order to assist some elderly living people. It can identify that if some person is falling down, then it can link to the ambulance service so that some healthcare measure can be taken. Now, how do you actually use this transfer learning in order to detect a deepfake video? In doing so, what the basic idea is that we take the deepfake video as a classification problem. And what we do is we actually, from the videos, we take frames. And this from this frame, we identify the faces. Once the face is identified, then their feature is extracted using the pre-trained models such as VGNet or ResNet or Inception or MobileNet. Once the feature is extracted, then we actually can use any kind of classifier to identify if this frame is fake or not, and on this basis we can identify that if the face if this video is fake or not. However, there is a problem. The problem is that the classifier will give us that if this video is fake or not. For example, here, if I input a video through my classifier, it says that if this is a fake video or not, or the manipulated video, but it will not give me what is the reason behind suggesting that this is a fake video or this is not a fake video, which suggests that generally our traditional AI is working like a black box model, which means that it can give us the result, but it cannot explain why it has reached to this result. What is the base of this research? It lacks interpretability. It lacks the fairness, and most importantly, trust. Because we just believe, okay, this is the accuracy of the model. That's why it is giving us this result. But we don't know why it is basically giving us this result. For example, suppose if you are using some kind of credit card applications and your credit card application has been rejected, then you might say that, you know what, my application has been rejected, but I don't know why, because this is what the customer has said to me. Likewise, if you are using an application that suggests the price of a house, then it will just suggest you the price that it could be like so much £1,000 or so much £1,000, but it will not say you that why it is suggesting this price, which means that it is lacking an explanation. It is lacking an interpretability. So the idea here is that once we actually classify our model, which can identify that this model is fake and this model is not fake, then can we actually make this classification model a model that can explain its decision, why it's reached to this decision? So how we can make this deepfake model explainable or interpretable? There are some ways that can be used. First of all, what are those features which are used in making this decision. So feature is very important. Using the feature important analysis, one can identify what are those features, what are those input, which is important in determining whether an image is real or not. Second important thing is visual explanation. Visual explanation shows how the deepfake video detection model works. Okay, what is the and in doing so, what we do is we actually create a heat map of the important area of an image or a video to show that how does the model uses the information. The model should be transparent. It should show us what is the data being used by the model, what is the algorithm used by the model, what is the evaluation matrix that is used for measuring the accuracy of the model. And very importantly, very importantly, we should have a human in the loop. The human incorporation in making the decision is very important, because if we enable the human in the loop, then only the model could be able to explain. So what is the challenge now? The challenge is to make the the deepfake detection explainable, because we have this ability these days where we can say that using a GAN or using a convolution neural network or using the transfer learning, we can say that this video is fake and this video is not fake. But what is the missing point at the moment is that we do not know what is the decision or what are those reasons that says that this video is fake and this video is not fake. What is how to answer this challenge? What is the remedy to this challenge? The remedy to this challenge is a new branch of science, a new branch of AI, and this is called as explainable AI. What is an explainable AI? Explainable AI is a AI which is transparent, which identify or which explain the model, what is the data used in the model, each step that is taken in the model, and it is accurate. And very importantly, very importantly, explainable AI makes the algorithm interpretable, which means that you can interpret the decision that is given to you or the solution that is given to you or by the algorithm. You can, and once you know once you can interpret it, then you can control the output of the solution. Similarly, you can explain the algorithm based on the explainable AI. So all these things brings the AI from one generation to the another generation. And in this generation, the focus is that it's not just that we want a model to be very accurate. We also want why the model is suggesting this answer. Can we interpret the model? Can the model explain its decision? This is the base of the explainable AI. Just to give you one more concept about this. In the black box model or in the AI model, for example, I'm doing a classification here and it's classified. It says this is an insect. But if I'm using an explainable AI and if it comes to a decision where it says this is an insect, then it will also tell me why it is an insect. It is an insect because it has got the 6 legs. So now it makes more sense that if it is giving a solution to me, then it also justifying its decision why it has come to this solution. In our machine learning domain, in our deep learning domain, what we have found that the explainability and the accuracy has got some kind of a relationship. So if you have a low accurate model, you can explain it very well. For example, random forest, for example, decision trees. We can explain it that what is the reason that this is done this way. However, as we move on from low accuracy to the high accuracy, for example, neural network, then the explainability power of this algorithm is very low. So we have high complex model which are not very much explainable, but they have got the high accuracy. Then we have a low explainable, low complex model which have got the more explainability, but they have the low accuracy. So there are different types of methods or the frameworks that is being suggested to incorporate in our solution to make the solution explainable. And these explainable AI framework that is being used are SHAP and LIME. what if tool, AIX 360, scatter. Today, I will show you some information about the shape to show you how does a shape tool can be used. And this is being offered in Python. Actually, you can use the Python, and there is a library of the shape, and you can use this shape in order to make your algorithm interpretable and explainable. For example, first of all, let me give you how does the shape work. The shape stands, or the name of the shape is Shapley Additive Explanation. It's a model which basically explains how different features affect to the output of a model, or what contribution to each of these features contribute in the outcome of a model. It explains the machine learning model by quantifying each feature that contribute to the model's output. As a single feature value contribute to the output differently, Shapley values is the average marginal contribution to each of the feature value across all the possible correlations. So you can use the shape works in the linear regression, in the logistic regression, in the tree-based regression, deep learning models for image classification, and various NLP tasks can also use the shape model. So the shape actually can be used. There are two things that we generally use in explainable AI. One is called as global interpretability, and the other is called as local interpretability. The global interpretability means that how much each predictor contribute to the model, which means that we can explain the model globally. Okay, and local interpretability means that we can explain the model for each instances that is being used in the training of the model. So each observation actually can be explained using the local interpretability concept. So I have just shown here some example of the shape, and the data that I have taken is from UCI machine learning repository. This is a data that defines the quality of the wine. It has got different attributes, for example, fixed acidity, volatile acidity, critic acidity, residual sugar, chloride, free sulfur dioxide, total sulfur dioxide, density, pH, sulfate, and alcohol. And then we actually use an XG boost model to find out the best quality wine. And then I applied the shape on it, or the shape tool on it. So that's what I have got. So once it defines that what is the best quality, yeah.
Can you please wrap it up first?
Okay, yeah. So this how it defined that what are the important features that one can use in order to define the interpretability of the model. So the conclusion is that we can detect the deepfake video, and not only we can detect the deepfake video using the explainability through the explainable AI, we can also define, or we can also justify what that why a deepfake video is termed as a deepfake video. What is the reason behind it that this video is not the real video? And we can use the tools such as shape or line to achieve this.